Okay, so in this video, this is AP Stats. We're going to do section 5.3. We're doing the objectives of use tree diagrams to model a chance process and calculate probabilities to evolving two or more events, and then determine if two events are independent. So it's kind of a two-part process here. So, first one. The general multiplication rule is especially useful when a chance process involves a sequence of outcomes. In such cases, we can use a tree diagram to determine the number of sample spaces. And the reason we like tree diagrams is because, for example, what if I wanted to roll 3 dice, right? If you try to roll 3 dice, let's say I have 3 dice, right? Technically, I can't do a two-way table because a two-way table is only for 2 categorical variables. I can't do dice, dice 1, dice 2, comma 3. That doesn't work out. So we like tree diagrams because if I have anything more than 2 things to compare, then I can use a tree diagram. Otherwise, it's kind of difficult to do a two-way table with 3 things. You only have 2 objects or 2 categorical variables in order to consider. So, for example, we'll do the flipping the coin in the tree diagram first. So the general multiplication rule is especially useful. We're going to do a tree diagram considering flipping a coin twice. Okay, typically, all right, I'm going to do the two-way table for flipping a coin twice so you can see what's going on. Okay, so you have coin 1, and then whatever, this is coin for the first flip, and this is the second flip. Coin, I should say coin 2, but this is technically the second flip. So in coin number 1, you have a half probability of getting heads and a half probability of getting tails. You have a half probability of getting heads and you have half probability of getting tails. So technically, to get heads on both times you flip the coin, you have a 1 and 4. You really have a 1 and 4 here for tails and heads. This is heads. And this is going to be 1/4 for heads, tails. This is going to be tails. Right, and you have a 1 in 4 chance here. All right, well, this is easily convertible into a tree diagram. So this is how you start. If you've never seen these before, well, get ready. If you have, then that's awesome. We start with your first branch. Because you only have 2 possibilities for your for your coin, if I had a 3-sided coin, which would be kind of weird, or a 4-sided coin, or, hey, we can do a 6-sided dice, right? Then we would have 6 branches if we had a 6-sided dice. But technically, I only have a 2-sided coin. So one side is going to be a heads, and that's a half probability. There's a half probability it might be tails. Well, on the first try, if you roll a heads, you still have a heads and a tails available on your second roll. So this is roll number 1. This is roll number 2, right? So you have a 1.5, 1.5, 1.5, 1.5 for heads or tails. And the way that you get the 1/4, 1/4, 1/4, 1/4 is kind of the same way I did it on the other one. Since it's equally likely, 1/2 multiplied by 1/2 gives you 1/4. So this is probably getting heads. This is 1/4 probability of getting heads, tails. This is 1/4 probability of getting tails, heads. This is 1/4 probability of getting tails, tails. That's a tree diagram. These are your possibility outcomes or probability outcomes with your sample space. So technically your sample space is heads, tails, tails, heads, and tails, tails. Okay, so then what is the probability of getting 2 heads? Well, that would probably be up here, so it would only be 1 in 4. And then the probability of, so this is the answer, 1 here, 1/4. That's your tree diagram. Now, this is a little too easy. This is obviously not going to all look like this, but they're probably going to look something like this. They're going to look like, let's see, the Pew Internet and American Life Project finds that 93% of teenagers use the internet, and of that 93%, 55 of online teens have posted a profile on a social networking site. What percent of teens are online and have posted a profile? Okay. So I'm going to do this in a two-way, and then I'm going to do it in a, do I want to do it in two-way? Not really. Okay, let's just do a tree diagram. All right, so you have two choices, right? 93% of teenagers use the internet. So that means 0.93 use yes on internet. All right, and of that 93%, you have 53% of them who actually have posted a profile. So profile. And then no profile. Okay, now, since it has to be either they use the internet or they don't use the internet, if that's 93%, this is better be 0.07 for no on internet. All right, and then if they don't really have internet, I don't know how, I really don't know how they're going to be posting anything to a profile because they don't really have internet. So technically, you don't have a yes profile. That wouldn't even make sense. So that means everybody who doesn't use the internet, there's a 0.007 chance, obviously, that they're not going to post a profile because that's all you have that's left. Okay? Now, out of these guys right here, 0.53 that have a profile, there still has to add up to 100%. So 1 point minus 0.53 should give you 0.47. So 0.47 have internet, but they don't have a profile either. So the question is, what's the percent of teens that are online, yes, on internet, and they have posted a profile? So what is 0.93 multiplied by 0.53? Okay, so what is that percentage? Because that's the number of people who have yes internet and yes on profile. Okay, that's the other tree diagram. Okay, and then the next one is two more examples from the book, which I kind of liked. I didn't want to get rid of these things. Okay, video sharing sites led by YouTube are popular destinations on the internet. Let's look only at adult internet sites. And then about age 18 and over, about 7% of adult internet users are 18 to 29, 45% are 30 to 49, and the remaining 28 are 50. Okay, 70% of the internet users have visited video sharing site. Do most internet users visit YouTube and similar sites? Okay, so just pretty easy to do. We just need 3 branches. So you have 27% are 18 to 29, 45% are 30 to 49, and 28% are 50 and over. So technically, in your tree diagram here, you're going to have 1, 2, 3 branches. One branch is going to be 0.27% for your 18 to 29 year olds. The next branch is going to be 0.45%. Sorry, not 0.45%. 0.45 for the 30 through 49 age group. And the remaining 28% is going to be for 50 plus. All right. So in each one, in the next branch, you either have that they do use internet or they don't use the internet. So yes, no, and yes, no. All right. So we find that 70% of the internet users 18 to 29 have visited a video sharing site. Oh, not profile. Sorry, video sharing site. So this is going to be 0.70. 51%, 0.51. And then the last one is 0.26. All right. Well, these have to add up to 100%. So like 27 plus 45 plus 28 adds up to 100. 70 plus something has to add up to 100, which makes it 0.30. 51 plus something has to add up to 100. So 0.51. What is that? 49. Oh, duh. I could have done that in my head. And then the last one. We got 0.74. Okay. So, draw a tree diagram to represent the situation. Check. Find the probability